factoring by grouping. We're going to do factoring a little bit by grouping, and then back to the method we talked about the other day in class. As we look at, so factor by grouping, here we're just looking at this, and this is like the very root or the base level of factor by grouping. I already have a group, and it can go either direction. If this is my group over here, AX plus AY, and I'm thinking, what do they both have in common? What is their greatest common factor? Their greatest common factor is A. So when I factor that out, I'm dividing both of these by A. So I have A out in the front, and I'm left with X plus Y, which is what this whole slide starts with. So just showing you, like, at that very beginning, in the past, we've taken this, we've done distributive property, AX plus AY, AX plus AY, and that's simplifying. And then factoring is backing us back out of that by looking for greatest common factors, which is where we've been talking. It's typically where we start, looking for a greatest common factor. And then we look and say, in a case like this, what is my greatest common factor? And I look at both of the terms, and I realize they both have a number in front that's divisible by 5. So I'm going to guess there's a 5 root coming out of both. Do they both have the same variables? No, they don't. This has z's, this has y's, so there's nothing there that can get factored out. So when I do it, 2 z squared plus y cubed. And you'll notice that's a 2, that's a z. They look very similar when I write them down, which is why I always cross my z's. So that's the idea first of looking for the greatest common factor. Sometimes it'll just be a number. Sometimes it'll be a number and a variable. Sometimes it will be nothing. So go ahead and take a moment. And I've already told you what the greatest common factor is on that one. Factor that out. I'll hit pause. You can do that on your own, and you got an answer. You can unpause and check. So like I said, this is the greatest common factor. I've given you that, so now you're trying to think of what happens, and I don't have enough room on that side. What happens when I factor that out of everything? Start with the numbers. 15 divided by 3, 5. Y to the 5th divided by y squared is what you're thinking, because that's what factoring is. Factoring is dividing out y to the 3rd, because our principles of exponents, when you have same bases and divide, I subtract 5 minus 2. Then I have minus, a negative 9 divided by 3 is negative 3. I have y squared coming out of y to the 4th, so that'd be a y squared. 27 divided by 3, 9, because this is not 3y squared is coming out. 27 over 3 is 9. Y squared over y squared is 1. There isn't anything for a y. It factors out, and then that would be it. So then that would be taking out and finding the greatest common factor from all three. This next thing that we have is not a quadratic, so we're not going to be doing the quadratic properties yet, because otherwise normally we'd get to here and then we go, okay, now can I do this for FOIL or reverse FOIL? And because this is not a squared, it's a cubed, we don't have a plan or a process right now that allows us to do this. So at this point, this would be done. That would be done at that point. So here I have, this is then the idea of factor by grouping. It's just as one long thread. I just want you to look at it for a second. Don't write it down until we've gone through it and you can process what we're talking about. So the original equation is up here. It's x cubed plus 4x squared plus 3x plus 12. As you can see, all four of them, the x cubed, the 4x squared, the 3x, and the 12, they do not have a greatest common factor. They have nothing in common. There's no number, there's no variable in all of them. So then what I look to do is, can I group pairs of them together in some way so that they have something to factor out of them? So this is one way I could group it. I could just literally take the first two and make a parenthesis around the two of them. And then the second one, to make parentheses around the two of them. They're still being added because they're all adding here. So I've not changed anything. I've just thrown some parentheses in there. Much like one of those first review problems, if there's parentheses that don't have anything going on, we can just drop the parentheses. Here, nothing's going on, so we just drop some parentheses into it. So after you've grouped them, and there is a logic to how you want to group. I want to group them in such a way that I look at two of the numbers, I go, oh, they're going to have a factor. They have something in common. Because if I look at the 3x and the 12, I can factor those two, because I can factor a 3 out of the 3 and a 3 out of the 12. And I'm left with, and I wrote something down wrong when I was plugging this in, that is not an x, because they don't have an x in common. They 3 and the 12 only have a 3 in common, so over here, I factored that 3 out, and I'm left with an x plus 4. Again, you're thinking factoring is the opposite of distributive property, so if I went 3 times x is 3x, 3 times 4 is 12. And then the first two, they don't have a number in common, but they both have an x. And the highest power I can take out of both of them is an x squared, which is why this over here is x squared. So when I factor that out of the x cubed, I'm left with x. When I factor the x squared out of 4x squared, I'm left with 4. So again, just distributive property, reversed it out by factoring out the greatest common factor of these two that I grouped together and these two that I grouped together. And then finally, if it's going to be factorable, I get to this point and I look and notice that this thing and this thing, because those are the two things I'm adding, they have a common factor. The common factor is x plus 4. So if I take the x plus 4 out of it and out of this one, I'm left with x squared plus 3. Now, it's possible if I take this x cubed plus 4x squared plus 3x plus 12, that was the original equation. What if I just rearrange this and I did x cubed plus 3x plus 4x squared plus 12? Because that is another way that I could group it. I could just group here and group here. Because, the reason why I did that, these have a common factor. They both have a factor of x. If I did that, I'd have x times x squared plus 3. And then I look at 4x squared plus 12. Do they have a common factor? Sure, they both are divisible by 4. So plus 4, when I divide 4 out of 4x squared, I have x squared. When I divide 4 out of 12, I have 3. And lo and behold, they have a common factor. So if I factor that out in front, x squared plus 3, if I factor the x squared plus 3 out of this, I'm left with x. If I factor the x squared plus 3 out of this whole thing, I'm left with plus 4. Which this and this are the same thing. We just rewrote them in a different order. In multiplication, you can do multiplication in either order. 4 times 3, 3 times 4, it's always going to be 12. A times B, B times A, it's always going to be the same thing. X plus 4 times x squared plus 3, or x squared plus 3 times x plus 4, it's the same thing. And that's the basic idea of factoring by grouping. So then we look at this, where all the spots are blank, and we think, all right, well, what am I going to group together? And the way it's nicely kind of written here for us, we're just going to go ahead and have these as a group, and then these as a group. So we look at those first two, and we look and say, well, what do they both have in common? They both have an x. And then after I factor that x out of the xy, I'm left with y. After I factor the x out of the 5x, I'm left with 5. Those next two, I've told you in this case, we're factoring out this negative. This negative I want out in front, so I'm going to factor out of each of these a negative value. And 4 and 20 are both divisible by 4. When I factor the 4 out of when I factor the negative 4 out of negative 4y, I'm left with a positive y. again, keeping track of your negatives, if you're going to factor out a negative from a negative, your result is a positive. And I'm going to factor a negative 4 out of negative 20, and I'll have positive 5. And then just like we did, they both have a y plus 5. When I look at this whole thing and this whole thing, they both have a y plus 5. So that y plus 5 is factored out of both, leaving me with x minus 4. So that would be the factored form for that equation. So if you don't know where to start, so this is getting to factoring like we've been doing it the last couple days, and then we'll do a little bit more with grouping near the end. If the last term is negative, when I talk about last term, I am talking about if I have an equation, ax squared plus bx plus c. If the last term is negative, so if the c is negative, so it'd be like minus 4 or something like that, that means then the two factors, when we factor it, like this, means the last two terms, this one and this one, the lasts in the FOIL, are opposite signs. One positive, one is negative. If the middle term is positive, then the bigger of these two lasts is positive. If the middle term is negative, then the bigger of the two factors is the negative one. So the last factor determines, well, yeah, let's go to the next one. If the last term is positive, so the last number here is positive number, then either they're both positive or they're both negative. So as we look at, we're going to go back to this. And the minute we see something like this and we're told to factor, and where you should start, you just start with the last term, negative 6. And you're thinking negative 3 and 2, 3 and negative 2, 1 and negative 5, negative 1 and positive 5. Because those are all the numbers that multiply to negative 6. Which pair adds to the middle term? The pair that adds, this adds to positive or negative 1. This adds to positive 1. Oh, that shouldn't be a 5. It should be a 6. We're multiplying to 6, not 5. Sorry about that. These add to negative 5. This adds to positive 5. This is my choice pair because it multiplied to the last term, adds to the middle term. But again, looking at those rules we had, it's negative, which means one's positive, one's negative. The middle number tells me that the bigger number is the positive one. So if I was doing this, I'm like, oh, the bigger number is positive here, but those don't add to 5. Here they do. So it's x minus 1, x plus 6. If you wrote x plus 6 times x minus 1, that is exactly the same thing. Both are fine. Same idea. What are we multiplying to? Just go ahead and... No, we're multiplying to 6. The last term is the multiplying term. And it's a positive 6. So they're both positive or both negative. So 1 and 6 or negative 1 and negative 6. 2 and 3 or negative 2 and negative 3. Which pair adds to negative 5? X minus 2, x minus 3. Same idea. What number are we starting with? 6. Is it positive or negative? It's positive, which means they're both positive or both negative. 1 and 6, negative 1, negative 6. 2 and 3, negative 2 and negative 3. Which pair adds to positive 5?
2 and 3.
2 and 3. It factors to x plus 2, x plus 3. As long as that first number, the first coefficient, the number in front of the x squared, is 1, this is the process every time. There might be some more challenging numbers, like this one. So now I'm saying, oh, I need two things that multiply to 6y squared. So what multiplies to 6? 1 and 6. What multiplies to y squared? Y and y. And it multiplies to a positive, which means they're either both positive or both negative. So negative 1y, negative 6y. 2y, 3y, negative 2y, negative 3y. And then I look and say, do any of these pairs add to 5xy? Wait a second. No, they only add, like this one will add to 5y, but not 5xy. Well, think of all those past ones we've done. The x comes from the first term. So if I did this, actually, let's do it by grouping. What would happen if I would take this and rewrite it as x squared plus, so this is what I want. The 2 and the 3, the positive 2 and the positive 3, seems like that might be the way to go. If I take this and unsimplify it into 2xy plus 3xy, right? Unsimplify means I'm just splitting it up into two things that would add to 5xy that I think might be related to this, and then I'll leave this as plus 6y squared. I now have two groups. Got this one, got this one. What will I factor out of that first set of parentheses? They both have an x. So I'm going to factor an x out of it. Left with x plus 2y. All right. Then I look at this second set. What do both of these terms have in common? 3 and a y. They both have a y in it. So 3y will divide out. And when I divide 3y out of here, the 3's reduce, the y's reduce. I'm left with just the x. When I divide the 3 out of 6, that's 2. I take one of the y's out of y squared and I get y. Look at that. They have something in common because I look at the whole of this and all of that, and they both have x plus 2y. So when that gets factored out in front, I'm left with x plus 3y, which is exactly what I had here, 2y and 3y. So while they didn't add to 5xy, they did add to 5y, but the x comes from the first part. So when I FOIL it out, I'll end up with that middle xy portion. I forgot to record that slide, but there's the solutions. If you work through them on your own, you can see it right there. But the procedure was numbers that multiply to the last term, because when you FOIL L lasts, the lasts will multiply to this number. Negative 3 times negative 3 is 9. 1 times negative 2 is negative 2. 4 times negative 2 is 8. And then you're looking for whichever pair adds to the middle term. So now to here. Don't let the big numbers fool you. Just start doing and saying, well, what multiplies to 99? Actually, negative 99. One of them's positive, one of them's negative. Well, 1 and 99. Negative 1 and positive 99. And what else?
11
33 and 3. Or negative 33 and positive 3. Or 9 and negative 11. Negative 9 and positive 11. And once you get a few, start looking at them and say, do any of them add to 2? Let's see, these add to negative 98. These add to 98. These add to 30. These add to negative 30. These add to negative 2. This adds to positive 2. There's my answer. Z plus 9. Z minus 11. So remembering your multiplications tables through 12, honestly, is it can help simplify and make things go quicker in that process. Then we get to a place of like, wait a second, we're missing something. We're missing the x term. So what you can do is rewrite it with the x term there. Well, it's not there, but it is there. But what's there that we don't ever write that's there? 0. If we have no x's, we typically write nothing. But now, this is what's going on. The 0x is there, we just never write it. And now I'm back to the same procedure. What multiplies to negative 9? 1 and negative 9. Negative 9 and 1, or that's the same thing. 1 and negative 9, negative 1, positive 9. 3 and negative 3, negative 3 and, well, that's the same thing. These add to negative 8. These add to 8. That's an 8. These add to 0. Oh, that's what I want. X plus 3. X minus 3. What do you think that's going to be? They need to multiply to the last one and add to 0. If it has to add to 0, one of them has to be positive, the other one has to be negative, because those are the only things that will add to 0. Unless it's 0, but that wouldn't work. So what are the two numbers? 4. Because if I FOIL this out, again, when in doubt, that's always how you can check. Firsts, x squared. Outsides, minus 4x. Insides, plus 4x. Lasts, negative 16. These add to 0, x squared minus 16. I'm going to go back to this one for a second. So, x squared minus 16 is called, it's got its own special name, difference of squares. And the reason why it's called difference of squares is if you look at the original thing, what times itself gives you x squared? Well, the answer to that is x, because x times itself. X times x is x squared. What times itself is 16? That's 4. And it's a difference, subtraction. Whenever it's a difference of squares for any difference of squares, it's going to be, really what you're looking at is the square root of the first one plus the square root of the second one times the square root of the first one minus the square root of the second one. So if I have anything, and it doesn't matter how it's written, if I have 25 minus y squared, that would be 5 plus y, 5 minus y. Square root of the first one plus the square root of the second one times the square root of the first one minus the square root of the second one. And then it gets really, it can get really, I say the word fun, messy. Have something like 36x squared minus 121y squared. All right, all of those are squares. It's going to be 6x and 6x. It's going to be 11y and 11y. One of them's plus, one of them's minus. Oh, so now moving on to this one. Take a moment, figure this one out, then hit unpause and we'll go through the solution. That's all there is. The only two numbers that multiply to 5 are 5 and 1. So either negative 5 and positive 1 or positive 5 and negative 1. They add to either negative 4 or positive 4. And I need them to add to 1. So in a case like this, this is
Unsolvable.
unfactorable.
Should you just
Unfactorable. When we get to solving quadratics, which is not too far in our future, if this equaled 0 and I can't factor it, I will eventually use what's called the quadratic formula, which is this, which some of you may have seen in your past and thought, oh my goodness, I'm glad I will never see that again. Well, ta-da, you are. Negative b plus or minus the square root of b squared minus 4ac all over 2a, which will give us a solution. So in this case, since it's r, it would be r equals, and that is only if I have my equation set equal to 0. And back to the question asked earlier, so what does that do? It tells me where it crosses the x-axis, which could be in a projectile motion type problem when it hits the ground. Last one that we're going to do before we walk out is this. Here we're going to be combining multiple steps. I'll just go ahead and run us through it. First step is, and has been, GCF. Is their greatest common factor? They are all divisible by 3, and they all have an x. And the x's that they have is 1, because the last one only has 1. I'm left then with x squared when I divide the 3 and the x out of 3x cubed. Divide the 3 out of 15, I'll have minus 5. Divide one of the x's out of x squared, I'm left with x. 3 out of 42, let's see, 3 goes into 4 one time, carry the 1 to 12. 3 into 12 is 4. And the x gets divided out, so it's done at that point. And then I'm thinking in my head, or writing down preferably, what multiplies to 14? Technically negative 14. 1 and negative 14. Negative 1, positive 14. 2 and negative 7. Looks like a z. It's a 7. Negative 2 and positive 7. And this one right here adds to negative 5. So my final factored form would be 3x times x plus 2 times x minus 7. And that's my last slide for today, which is perfect because it's now the end of class. See you next time.